Problem number 6. Find all types of parameters for an ideal transformer of 1:n turn ratio. Okay, here is an ideal transformer, 1:n turn ratio it is having. So the dots are given like this. Sometimes it doesn't give dots, but the default position of the dots will be definitely this one only, right? I already explained in the dot convention. So 1, 1 dash and 2, 2 dash, right? All types of parameters is asking. This is ideal transformer. What do you mean by ideal transformer? No resistance, no reactance. Yes or no, all of you, okay? We already, no leakage flux and no power loss. So we already discussed this matter in the magnetic coupled circuits. Now, if we do this, what is the relation that you have? Treating the primary terminals as first put terminals, V1 and I1. Treating the second put terminals as, secondary terminals as second put terminals, port 2, that is I2. Generally, in the two-put network analysis, we inject the current like this, but in the transformer, we generally draw the current from the secondary terminals. So let us follow now the relationship here, V2 by V1 is equal to N by 1. This is one equation. I2 by I1 is equal to 1 by N, but I1 should enter, I2 should leave from the dot. Therefore, there is a mismatch, but it is entering, right? Therefore, 2. So to get Z parameters, in Z parameters, you must express V1, I1 in terms of V1, V2 in terms of I1, I2. And in Y parameters, I1, I2 must be expressed in terms of V1, V2. Is it really possible using these two equations? Expressing V1, V2 in terms of I1, I2? Or I1, I2 in terms of V1, V2? Is it possible? You can make a try, or you can try once. I'm sure that it is not possible, because V2 can be expressed in terms of V1, I2 can be expressed in terms of I1, or else V1 can be expressed in terms of V2, I1 can be expressed in terms of I2, but you can't really express V1, V2 in terms of I1, I2, or I1, I2 in terms of V1, V2. It's not possible. Both the things are not possible. Therefore, from 1 and 2, it can be observed that from 1 and 2, it can be observed that, it can be understood that Z and Y parameters are not possible. Okay, Z and Y parameters finding or does not exist otherwise. You can say doesn't exist, otherwise you can say does not exist. You can write like this otherwise. Does not exist. Clear all of you, okay? But you can find the remaining parameters, because in ABCD parameters, you can see V1 is equal to, from this you can write that, V1 is equal to 1 by N V2 minus 0 times I2. Okay, from 1 you can write like this. From 2 you can write I1 is equal to, what do you write? I1 is equal to 0 times V2 minus N I2. Yes or no? From this you understand the transmission parameters will be 1 by N, 0, 0, N. Yes or no? This is A, this is B, this is C, this is D. Getting? Okay. Now, definitely is not symmetric, but reciprocity, yes, definitely AD minus BC is equal to, what is AD? AD is nothing but 1, BC is nothing but what? 0. Therefore, 1 you got. So, it is a reciprocal two-put network. Ideal transformer is a reciprocal two-put network. Note down. Ideal transformer is a reciprocal two-put network. It's a very important conclusion. Now let's go for hybrid. You can find even A dash, B dash, C dash, D dash in the similar manner. But now I go with I go for hybrid parameters. Hybrid parameters, what is the relationship between the variables? V1 is equal to H11 I1 plus H12 V2. Yes or no? Okay. And I2 is equal to H21 I1 plus H22 V2. So let's do that. From 1, V1 is equal to 0 times I1 plus 1 by n V2. This is one equation. This is 3. This is 4. This is 5. Now I2 is equal to minus 1 by n I1 plus 0 times V2. This is 6. Therefore, H matrix will become, if we compare with the standard equations of H parameters, 0, 1 by n, minus 1 by n, and 0. Okay, it is also reciprocal because H12 is equal to minus H21. You can see H12 is equal to minus H21. It is a reciprocal. Yes or no? Please note down this. Even inverse H parameters also can be determined in the similar manner. Please note down. Let's go for problem number 7. I think you have done that. Find an equivalent symmetric lattice model. For a given symmetric T model. Okay, a symmetric T model is given. For that, you need to construct an equivalent lattice model. Okay, so how do you do that? First T model, let us see. I'm taking the solution here. This is the T model. So this is given actually, and you are supposed to construct a symmetric lattice model. So what is symmetric lattice model? You know very well. Already you have seen what is symmetric lattice model. This is ZA, this is ZB, and ZB, right? This is a symmetric lattice model. So two two-port networks are equivalent when their parameters are same. When the parameters are equal. Suppose Z parameters here, Z parameters there. If you equate, if they are equal, then they are equivalent. Okay? If ABCD here, ABCD there, if they are equal, then they are said to be equivalent. Okay? So we already determined Z parameters of this particular lattice model. We already know what is Z parameters of this. What is the Z parameters of this? Z parameters of T model. Let us assume that you are given. Let us assume that you are given Z11, Z12, Z21, Z22. You are given these values, let us say. But you already know that symmetric, let us assume that ZA, ZB values. With that, you can imagine what is a symmetric lattice model. Okay, so Z of lattice is, you already know that ZB plus ZA by 2, ZB minus ZA by 2, ZB minus ZA by 2, ZB plus ZA by 2. Okay? Both the two-port networks are said to be equivalent if their parameters are same. Understand? Okay? Therefore, Z of T model, because he said equivalent, he want an equivalent symmetric lattice model. So, therefore, Z parameters must be same. Z parameters must be same. Lattice. From this we understand ZB plus ZA is equal to Z11 okay, by 2. From this ZB plus ZA is equal to 2 times Z11, equation 1. And ZB minus ZA by 2 is equal to Z12. From this we understand 2Z12. Solving these two, ZA, ZA gets cancelled. 2ZB is equal to Z11 plus 2, Z12, 2 gets cancelled, and finally you get what? Okay, ZB is equal to Z11 plus Z12. What about ZA? ZA is equal to, this is minus, this is plus, this is minus. It is Z11 minus Z12. So therefore, ZA is Z11 minus Z12. ZB is, from this 1 and 2, equation solving, okay? Solving the two equations, Z11 plus Z12. This is very, very important. Okay, sometimes in the exam, he will intentionally give you, this is ZB, this is ZA. Then everything will be reversed. Yes or no? It will become ZB plus ZA by 2, but ZA minus ZB by 2. In such case, you will get what? This will become ZB, this will become ZA. You must be a little careful. Because in the 4 options, 2 options will be confusing with these formulas. Okay, you must remember, we have proceeded with ZA, ZB. Right? Sometimes he may change, he must be careful. Please note down this. So I have constructed an equal. Problem number 8. Problem number 8. Determine Thevenin's equivalent. Determine Thevenin's equivalent. This is what the problem given. See, the parameters are given in this problem, and he's asking now determine Thevenin's equivalent. Okay, indirectly is asking the variables. He might be interested in either V2 or I2 or V2 I2, both sometimes. But indirectly will ask. Look at this. Look at this, all of you. What is Thevenin's equivalent? First of all, you see there is a two-port network embedded in the network. Where is the two-port network? You have to identify the terminals of the two-port network. This is one terminal, output port. This is the input port. Yes or no? This you have to identify first. Okay. If you say this is V1, the current here I1, this is V2, the current here I2, then based on those relationships, this box is prepared. Black box is described by H parameters. Understand, all of you? Okay. Now, when H parameters are given and described by H parameters, he is expecting what is the voltage across this VAB. But according to the terminology of the two-port network, what does this tell me, all of you? V2. What about this? I2. What about this? I1. This is V1. It is not given, but I am able to identify that. Yes or no? Okay. So that is already given in your classroom workbook. Please check with the problem clearly. And now here is asking V2. But what is V2 or VTH? VTH is nothing but V2 only, because already the loader is removed. But under the condition I2 0. Yes or no? VTH is nothing but V2 only under the condition I2 0. So if I am able to find V2 now with the condition I2 0, then my job is over. And then I need to find RTH or ZTH. That's a different story again. Definitely the reduction is not possible here because we don't know what is the background of the two-port network. What elements and how they are connected, I can't really find. Wherever reduction is not possible, there the equivalent resistance can be calculated, or Thevenin's impedance or resistance can be calculated using volt-amp technique, or else VOC by ISC method. We have got two methods. I think you remember. There are two methods we have described under the condition that where the reduction is not possible. Particularly in dependent source problems we have seen. When the dependent source problem is given and you are asked to find Thevenin's resistance, you got two methods. One is the formula VOC by ISC. The other is volt-amp method. Two methods are there. Sometimes I told you the method 1 fails. Yes, sometimes method 1 fails. But method 2 is volt-amp method is a versatile method. To apply volt-amp method, I told you already that you have to suppress all independent sources in the given network. Okay, so we will do that. Now, RTH we can calculate later. First, let us find out VTH. Now, let us write the equations of this pertaining to this H parameters. From that, we will try to identify the V2 value under the condition I20. Understand? So, can you please tell me here? Already the values are given. I substitute values later on. So, let me write the equation. So, V11 is equal to H11 I1 plus H12 V2. Equation 1. I2 is equal to H21 I1 plus H22 V2. Equation 2. All these values are known. These variables we do not know. But let us apply this condition. Under this condition, if you find V2, that is called VTH. Therefore, I2 0. Okay. Now, out of four variables, okay, you got three equations. But you need four variables, four equations. Yes or no? How do you find the other equation? You see V1, I1, 60 volt, 40. Can you write some relation among these? Yes, you can. Yes or no, all of you? You can write the relation. Tell me what is the relation. V1 is equal to, okay, V1 is equal to 60 minus 40 I1. I hope you understand this. So V1, if you substitute here, V1 is eliminated. I2 substituted here, I2 is eliminated. Then you get two resulting equations. If you solve them, you will get V2 as well as I1. But you don't need I1. You need only V2. I hope you understand. So solving 1, 2, 3, and 4, you will get V2. Now VTH is nothing but V2 only, because you found this V2 with the condition of what? I2 0. That's nothing but VTH only. So if you solve that, I'll give you directly the answer. You please try after substituting all these values in these equations. Okay, I'll give you the answer directly here. Minus 29.69 volts. Got it, all of you? Okay. You try. You take some time and then finish it off. Now, I want to find RTH. I got two methods. Method 1. RTH is equal to VOC by ISC. Okay. Method 2, volt-amp method. So I just find first method 1 using method 1. I have VOC. VTH is nothing but VOC. I need to find ISC. What is ISC? ISC or I Nortons all are same. This is nothing but I2 only. But I2 flows in this direction. ISC is required in this direction. The load draws the current, right? The load draws the current. Norton's current is nothing but load current. But load draws the current. So the current flows in this direction. But in our two-port network representation, the variable is shown in the opposite direction to the load current direction. Therefore, you must take it as minus I2. But under the condition, V2 is equal to 0. That's it. Okay. So, take the same equations. V1 is equal to H11 I1. Let me write again. H12 V2. Equation 1. I2 is equal to H21 I1 and H22 V2. Look at this, all of you. Don't write anything. Look at this. Now I want to find I2. My objective is to find I2 and apply minus to it. Then you will get ISC. Already you got VOC. Find the ratio of these two. You will get RTH according to method 1. Okay. We will also apply method 2. That is Oldham technique. Wait for a moment. So let me apply V2 is equal to 0. 3. And I also have V1 is equal to what? 60 minus 40 I1. That fourth equation is as it is. Yes or no? Fourth equation. So using all these 4 equations, can I find I2 or not? It is possible. First I eliminate V1, substituting here. I eliminate V2, substituting V2 is equal to 0. Finally I am left with what? V2 0, but I want I2. V1 when you substitute here, entire equation is in terms of what? V2 0 and 60 minus 40 I1 is equal to H1 I1. I'll directly find I1 value. Substitute that I1 here, then you will get I2 because already V2 0. Therefore, solving 1, 2, 3, 4. From 1, 2, 3, and 4. Looks like 4 equation solving, but it's an easy process. You see, 4 is substituted in 1. Already V2, 3 is substituted in 1. What will happen? V2 got 0. Entire equation is in terms of I1 only. Get the value of I1. That's it. Okay. 60 minus 40 I1 is equal to H11 I1. So 40 I1, if you send it that side, 40 plus H1 is into I1 is equal to 60. So 60 by 40 plus H11. What is that? 60 by 40 plus H11. Okay, you will get 1 kilo. That's it. So you will get the value of I1. And you substitute that I1 here, you will get the value of I2. Already you know H21. So substitute here, 60 by 40 plus H11 is nothing but I1. Already H21 is there. What is H21? 10. Then you will get I2. So you get I2 value here. And the I Nortons or ISC is nothing but, okay, minus I2. Got it all of you? Okay. So you will get some value here. You will get some value here. That value I can directly give you. What is that value? I can quickly give you. Okay. Okay. Minus 0.576. 0.576. So you get minus 0.576 amperes. Got it? Okay. You have to get this value. So this is how you calculate, because tomorrow you may be asking you what is the Norton's current. Find the Norton's equivalent. This is how you need to apply. Now, RTH method 2, Oldham method. You can calculate RTH using Oldham method. Yes, both the methods are important, I am telling you, depending upon the situation you are supposed to apply. So according to Oldham method, you have to suppress all independent sources. Independent sources must be suppressed. Must be suppressed. If you suppress, what do you get? Tell me. This is H. This is 2 dash. And you are suppressing here the voltage source. What is the value here? 40 ohm. Right? You suppress the voltage source. Voltage source is replaced by short circuit. So this is 1 dash. So what is your interest? Your interest is to determine, okay, RTH. This is what RTH you are supposed to find. For that Oldham technique, connect the voltage source. Already this is V2, this is I2. So if I am able to find V2 is equal to something into I2, that something is nothing but RTH, because Thevenin's equivalent resistance is nothing but what? Resistance measured across the terminals where the load is thrown off, with all independent sources suppressed. Yes or no? Okay. Now here, you again take the equations. Equation 1, 2 is common again. Again take the help of it. So you must be very fast in the calculation part, I am telling you, without any mistakes. This is equation 1. And I2 is equal to H21 I1 plus H22 V2, right? And you got some more. This is V1, this is I1. Can I write V1 is equal to, because 60 is not there now, minus 40 I1? Yes. Yes or no? Because this current will give you plus minus, but already you have plus minus, opposite polarities are there. Now, these are the 3 equations. Out of these 3 equations, you require V2 is equal to something into I2. Now, can I eliminate V1 by substituting here? Yes or no? I substitute here V1, that equation 3 in 1 and eliminate V1. Now V2 I'll get in terms of what? I1, or I1 in terms of V2. That you substitute here in the second equation. Then I1 is also eliminated. Then I2 and V2, the entire equation will be in terms of. Then you will get V2 is equal to something into I2. Therefore, 3 in 1 and get I1 is equal to something into V2. Call it 4. Now 4 in 2, get V2 is equal to something into I2. Okay, 5. This something is nothing but RTH. The RTH value you will get, okay, I'm giving the answer, it's there with me, 51.46 ohms. You can check here, already you got minus 29.69 divided by 51.46, you will get minus 0.576 ampere, that's ISC. Or else you already have these two values. So you get RTH is equal to minus 29.69 by minus 0.576 will also give you 51.46 ohm. I hope you understand the point. Okay, this is how you determine Thevenin's and Norton's equivalence, and also the Thevenin's and Norton's resistance. That is particularly very important using both the methods. So I covered VTH, I covered I Norton's, I also covered RTH. So it's very, very interesting and important. Please note down quickly here. Ninth problem. Find Zin, input impedance. H11 2 kilo ohm, H12 10 power minus 4, H21 100, H22 10 power minus 5 Siemens, and here is some 50 kilo ohm. We're just asking Zin, input impedance. Okay, whether it is input impedance or Thevenin's equivalent impedance, the procedure is same in case of two-port networks. Yes or no? So what is the procedure to find Zin now? You are left with only one option, that is what? Volt amp method. Yes or no? So according to volt amp method, suppress all independent sources. But here there is no independent source at all. You can connect a source across the terminals where the resistance or impedance required and inject some current. Already this is 1 dash terminal according to the two-port network representation. This is 2 dash. This is V2 already, and this is I2. Based on this relation only, now these parameters were already determined. Okay. Now, what are the parameters given? First, you write the equations pertaining to those parameters. So, what is V1, H11, I1 plus H12, V2? Equation 1. What is I2, H21, I1 plus H22, V2? Equation 2. Now, what do you get here? V2 is equal to minus 50 K, that is 10 power minus 3, I2, equation 3. Understand? So, from this you clearly understand the V2 is substituted in both the equations. If you substitute in one, okay, if 3 is substituted in 1, then what do you get? Tell me. Okay, V2 is eliminated. Yes or no? If we or else you can substitute 3 in 2, otherwise 3 in 2, then V2 got eliminated, this entire equation will become what? I2 and I1 in terms. So you can express I2 is equal to something into I1. Yes or no, all of you? Okay, this is one way. Or else you can see here V2 you can substitute here, V2 you can substitute here. This equation will be in terms of V1, I1, I2. This equation will be in terms of I2, I1. That's it. Yes or no? Okay, so I2 will be something into I1. Let us say this is 4. And if you substitute 3 in 1, then you will get V1 is equal to something into I1 plus something into I2. This is 5. Now again substitute this 4 in 5, eliminating this I2. Yes or no? Entire equation will be what in terms of V1 is equal to, you will get something into I1. This is what you require Z in. I guess you understand this, okay? So this is how you have to manage all the equations, okay, given pertaining to DH parameters. You can manage them and find Z in value. I'll give you the answer here, but this is what the mechanism you can apply. It's 1.667. Z in is 1.667 kilo ohm. .667 kilo ohm. Note down that quickly. I'll give another problem meanwhile. 10th problem. 10th problem. .1 Siemens, and this is 2. This is 50 volts. Find RL for which it receives maximum power and also find the maximum power value. 10th problem, you can go through your classroom workbook. It is clearly given. What is he asking? I read, find RL for which it receives maximum power and also find the maximum power value. What is given actually here? Transmission parameters are given. T stands for transmission parameters. If the two-port network is described with the transmission parameters, okay, then determine RL for which it receives maximum power and also find the maximum power value. Okay, so let's do that. Let's do that. Now, what is the maximum power transfer condition? The condition for maximum power transfer in the case of DC circuits, it looks like DC only, right? It's not AC. If it is AC, again, you are supposed to maintain that relations. I told you already in case of DC and AC. Okay, the condition for maximum power transfer is what? RL is equal to RTH. This is what the condition for maximum power transfer. And PL max will be VTH square by 4 times RTH. This is the maximum power value. So from this we understand that we require VTH as well as RTH. So finding RTH directly when somebody is asking, let us say, then better you go for old time technique. There is no need to find VOC, ISC. 2 times you are supposed to solve the equations. Yes or no? Because their conditions are different. In one case you are supposed to apply I20, the other case you are supposed to apply V20. So solving the equations for both the conditions will be again time taking process. If in the question it is asked directly condition for maximum power transfer, that is RTH required to find RL is equal to RTH, better you go for old time technique to find RTH value. There ends the matter. If maximum power value is asked, VTH and RTH are required. Once you find VTH, then RTH can be determined either by finding ISC to find the ratio, or else you can directly use Oldham technique. That is of your choice. But when only RTH is required, better you go for Oldham technique. Understand? Okay. Well, so what is VTH now? To find VTH, the procedure is very simple. This is plus minus V1, I1, I2, and plus minus V2. So I just write the equations. V1 is equal to A V2 minus B I2. Equation 1. I1 is equal to C V2 minus D I2. Equation 2. I want that I2 0 condition, because you know that VTH, under VTH condition, what is VTH? VTH is equal to V2 under I2 0. Yes or no? Therefore, this is third one. Another one is what? V1 is equal to 50 minus 10 I1. So solving all this, V1 can be eliminated, I2 can be eliminated. From the resulting two equations, you can get V2, that is 10 volt. This is nothing but VTH or V2, both are same, 10 volts. Now, the procedure to find RTH. Okay, the procedure to find RTH. I am using Oldham technique. Oldham technique. I am not drawing the network again because I already done the same problem in the H parameters in the previous problem. I think 8th problem I have done already. You have to suppress this particular one, right? This is a procedure to find RTH. You remove it and connect the source across the terminals where the resistance required and inject some current. Now this is the arrangement for finding RTH. Yes or no? So the same equation 1 can be taken here again. There is no difference at all. The same equation 2 also. Let me write clearly again. AV2 minus BI2 and I1 is equal to CV2 minus DI2 and V1 is equal to, what is V1 is equal to? 0 minus 10 I1, right? From this you can eliminate. You can eliminate V1 as well as I1 and get V2 is equal to, from 1, 2 and 3 you will get V2 is equal to something into I2. This something is nothing but RTH. This RTH value you are supposed to get 10 ohm. Sorry, 8 ohm. Okay, you are supposed to get 8 ohm. That's it. So now condition for maximum power transfer. RL is equal to RTH is equal to 10 ohm is one answer. The other is PL max is equal to VTH square. How much it is? 10 square by 4 times RTH. 3.125 watt. Please note down. Okay, so this is how you solve the problems when